Okay, kids, 5-5. We are cruising through this chapter. If you look ahead, these notes are also pretty short. So this, we're going to look at how to integrate bases other than e. We already know how to integrate e to the x, right? That was pretty easy. What if the base is not e? So there's a method where you can convert to base e. I'm going to skip that and go right to the formula. For me, I think that's easier. What the formula says is, do you guys remember if you integrate e to the, let's look over here. If you integrate e to the u, you just get e to the u plus c. This is going to be really similar, except when you integrate a to the u, you're going to get a to the u. So that part's similar. You just have to remember to divide by natural log of a. So natural log of this base. We essentially do it over here also, but what is, so again, this is natural log of the base. If you divide by natural log of this base, which is e, what is natural log of e? Isn't that 1? So we never really analyzed it in that case. Okay, so again, the formula is copy, this is a number, like 5 to the x. You copy the whole thing over and then divide by natural log of 5. Easy enough. Look at the first one. This is not e to the x, is 4 to the x, so we have to remember that extra piece. There's no u sub. This is just the formula, a number to a letter. It's 1 over natural log of the base, and then copy it over from -1 to 4. Remember that natural log of 4 is a scalar, so I'm going to write 1 over ln 4 in front. I'm going to add 4 to the 4th minus 4 to the -1. I'm just using first fundamental and throwing those in. I have 1 over natural log of 4. 4 to the 4th. A quick way to do this, if you don't know 4 to the 4th, it's 4 squared times 4 squared. So 16 times 16. I don't know if that's any easier. That's 256 minus 1/4. If you get common denominators, it's going to turn into 1023 over 4, and then we have the other ln 4. Okay, we're already done with number 1. So again, the rule, copy this over, divide by natural log of 4. Okay, now this one, we're going to know this is from 5-5, and here's why. We have a number raised to a power. This is not e raised to a power, it's a number raised to a power. So u sub, here we come. U is going to be the exponent, which is 4 should go in those parentheses, 4 minus x squared. So du, chain rule, we'll bring the 2 down. We copy 4 minus x over, and then the derivative of the inside is negative, and then we have a dx. So now when I go to my substitution, remember, you know what I'm going to say, I copy u over first. So 5 to u, because this was my u. So I have 5 to the u. Look what I have left. I have a 4 minus x and a dx. Here's a 4 minus x and dx. I need to get rid of the -2. I'll divide it over and I get -1/2 du. Now this is the formula right here. Copy this over, divide by natural log of a. -1/2 is a scalar. Copy this over and divide by natural log of the base. Plus c. Notice on the last one, this was definite. This is not definite. Indefinite, if you will. Okay, we have a couple scalars going on. You guys see them? We have this guy and this guy. Let's put those together, and let's replace u. Okay, so we're going to have negative, and then in the bottom is 2 natural log of 5. The numerator is 5, and u is 4 minus x squared plus c, and we're done. Okay, that's really it for the calculus, guys. Simple formula. It's so easy. I know I make the mistake too of forgetting to divide by that natural log of 5. Just keep telling yourself this is just like e with a little twist. Okay, now this is compound interest. You guys have seen this stuff before. One thing to note though, I don't know if you've ever seen e like this. So we're starting to talk about natural log and e quite a bit in calculus. If we apply the limit, so as n goes to infinity, as n goes to infinity, doesn't this go to 0? But it's not quite 0. So I have 1 plus some itty bitty number raised to a huge power. Oddly enough, that is e. And that is, if you remember, 2.71828, da 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 da. Okay, so 2.7, 1828, 1828, etc., etc. That's a neat way to look at this. Do you guys remember the interest formula? This is your principal. It's 1 plus, this is your interest rate divided by how many times you've compounded it. So if it was monthly and a 6%, you would say 0.06 divided by 12, and then it'd be 12 times the number of years, because if you compounded for 2 years, 12 times a year, that would give you your 24. And I'll walk you through an example also. If you compound continuously, that's like on the second, right? The second on the second. I want you to see kind of where this formula comes from. I don't know if you remember PERT from last year and Algebra 2, but I'm not going to go through the proof, but can you see how this was E? If you compound continuously, that means an infinite number of times. Can you see the ones? Can you see things kind of matching? Again, I'm not going to go through the formal proof, but I at least want you to see where the E, why the E is there. Okay, the amount of the deposit is your principal, which is P. The number of years is T for time. The balance at the end is going to be your capital A. The annual interest rate is your R, and the number of compoundings is N. So when I said monthly, that would have been 12. I bet you really could finish these last two on your own. I'll go ahead and set them up with you. So determine the amount of money that should be invested. This is a common question, right? You want to know how much you need to have now to have a certain amount in the future to produce a balance of 100,000. So 100,000 is what I want to end up with. P is the principal. I don't know what I'm doing with that. That's the question. Now it said compounded continuously. This means PERT. Compounded continuously is PERT. So we have P times E. The interest rate is 0.03 and the time is 30. It's really picking up your calculator and typing this in. This, I'll give you like about what this is. It's going to be, let's see. This is about P times 2.46. But again, I'm not using this decimal. I'm keeping it all in my calculator to get a final principal of 40,656.97. So I would need to invest $40,656.97 to end up with 100,000 in 30 years. Because it said continuously, we said we're going to use PERT. Now compounded daily. So not quite as fast as continuously, but still quite a bit. We're going to use the top formula. I had to get off the page, but if you need to flip back, you know what, instead of you flipping back, I can copy it over for you. Okay, I want to still end up with 100,000. There's my principal. 1 plus the interest rate is 0.02 divided by 365, because that's how many days in a year. And then it's how many times it's compounded times the number of years. How many years? 30? Okay, 100,000. And again, if you just type this in on the right, I'm going to go ahead and do it. I'm not going to bother pulling up the calculator for it. You guys know how to type this stuff in, but if you're not getting the right answer, let me know when we meet. And I got about 1.822. Divide both sides, but don't use 1.822. Use the whole string in your calculator. And you're going to get 54882.07. Let me double check that. Spot on. Okay, so we need 54,882.07. So we're going to need a little more than we needed with a continuously because it's not being compounded as much, right? Continuously is a lot faster than daily. Okay, believe it or not, oh my gosh, under 10 minutes and we're done. Okay, use the extra time to study this formula. Make sure you have it down. Okay, copy it over. 1 over ln A. You got it. Okay, see ya, kids.